Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering. In this season of the Analytics Engineering Podcast, I'm digging deep into the world of developer tools and databases. And there are few more widely used developer tools than Docker. From its launch back in 2013, Docker has completely changed how developers ship applications. It's hard to imagine going back to a world pre-Docker, where shipping code between environments was incredibly effort-intensive. But how exactly does Docker work? I still remember my first experience building and running a Docker container, and the experience was magical. In this episode, I had the very good fortune to talk to Solomon Hykes, the founder and creator of Docker. We talk about the problem Docker solves, the technology under the hood that enabled Solomon and his team to solve it just over a decade ago, and where the Docker journey has gone since then. Layers of abstraction are how computer science makes forward progress, and Docker is a critical one. I'm pretty confident that after every one of us listening to this retires, Docker is still going to be used in production for a very long time. It was a ton of fun to get to speak to Solomon about it. Without further ado, let's get into it. Solomon Hykes, welcome to the Analytics Engineering Podcast.
Thank you. Thanks for having me.
It is awesome to have you. We met at a reInvent last year. Is that right?
Yes, I think that's right.
We were on stage. It's always fun when you throw a few people together on a panel on stage and they like each other. It was you and me and Erica from Redpoint, I think. Is that right?
Yep.
So we had a good conversation about open source. Eric had been involved in GitHub. I want to get you to give a little background on yourself, where you've been, what you've been up to for the last couple decades. But it is, I think many people will know you as the person that kicked off an avalanche that changed the way that lots of us interact with our compute environments by, is it fair to say, inventing Docker? Is that the right word to use?
Yeah, sure. I'll take it. Discovering Docker? I don't know.
Tell us about the story of the Solomon journey.
Sure. Well, definitely Docker is the thing I'm known for. Pre-Docker, I grew up in France, even though I don't sound French. I studied programming in a French school called Epitech. That was sort of an unusual school, brand new. No one, I think, had graduated and had gone through the whole 5-year program yet. It was very different and scary, but it was all about nonstop programming all the time, learn through practice. And I loved that. So straight out of high school, went there and then got pulled into, got exposed to the world of startups as a complete outsider. Didn't know anyone who worked at one, didn't even know really how that would work. But through chance, I met someone who told me about it and then kind of got stuck in the back of my mind.
And you're still in France at this point?
Yes.
Yeah.
Yes. And then anyway, eventually I gave it a shot and, moved into my mom's house in the suburbs of Paris, worked out of the basement, struggled a little bit. And then by complete random luck, got into an early version of Y Combinator in 2010. And that got us on the path to what would become Docker 3 years later. So 2013 is when we pivoted from what we had before to Docker.
It was originally, the thing that you were building was called .cloud, is that right?
.cloud, yep. I mean, it was very related. It was about container technology and its awesome potential and our geeky excitement related to that technology, but not knowing exactly, okay, how do we take this to market, and just churning and trying different things. And .cloud was about using the tech to deploy and host people's applications kind of all in one, platform as a service, as it was called. And we competed with Heroku and a million Heroku clones, basically.
When did that whole wave kick off? When did Heroku become a thing?
Heroku became a thing, at least the first time I became aware of it was 2009.
Okay.
Just as I was struggling back in France to make something of this container tech that excited me. And then we decided to, when we joined Y Combinator in 2010, we packaged that raw technology into .cloud, which became an application deployment and hosting platform. And that became our differentiator. We used containers under the hood when others didn't. And that allowed us to support many language stacks, for example.
Mm-hmm.
We even went so far as to run databases on containers, which back then was like completely unheard of.
Yep.
Even for the small number of people who did know about containers, running databases on them was like even more weird. It turns out platform as a service is a tough business. Pretty much all those startups went out of business or got acquired, early. And, eventually we pivoted to just opening this container tech that had been maturing under the hood and going from, selling the car to building an ecosystem around the engine, and that became Docker.
Did you move in that direction because the selling the car part wasn't working? Or was it just like people saw the engine and they kept pointing at that and saying, like, give me that thing?
It was a little bit of both,
Yeah.
just not quite enough pull. I mean, you could definitely make a business out of deploying and hosting people's applications, but it was just a very difficult one because you had to spend a lot of money to get developers to try your platform because it was very competitive, right? Picture these days it would be the equivalent of trying to compete in agentic IDEs or something. Just a lot of money to market. It's almost like it becomes gradually more and more expensive to the point where it starts feeling like consumer marketing almost. And developers expect all this free stuff, and this is further complicated by the fact that you're selling hosting and wrapped in awesome tooling. It's hosting. Hosting costs money. Someone's got to pay. If developers demand free hosting to even give your product a chance, and your competitors are giving it to them, there's a lot of pressure on that acquisition cost coming in. And then margins were under pressure from AWS that was just turning into the giant that is today. So it was just there was always demand, but it was just a difficult business, frustrating one. Felt like pushing a boulder uphill. And then on the side, yeah, there was demand for something else. There was this pull. Like, for example, people wanted to run things locally. Why can I only run? You had all these proprietary platforms, and you couldn't really replicate them locally. It was all built on open source bits, but then it was wrapped in this proprietary remote, envelope. So just being able to run it locally was commonly requested. And then there was just no ecosystem, no ability to customize it, make it your own. It was sort of a black box. That was always the weakness of platform as a service.
Before we go to, there's like 10 threads I want to pull on just from this part of the story. But before I get too carried away with myself, could you maybe just define Docker and define what is containerization? And maybe as a part of that, like, how is that different than the word virtualization?
There's two layers to it. There's the raw technology, which is a form of virtualization. With virtual machines, VMs, you can split up a physical machine into several virtual machines, so it appears like you have more than one, and then you can sort of pretend that there are more than one. Right? It gives you this more flexible unit for managing machines.
And that happens at like every resource every hardware resource that a computer has. It has its own memory, it has its own storage, etc.
Memory, compute, storage, exactly. Yeah. And that was, the slicing up was imperfect in the early days. It was just kind of good enough, and then over time it got better and better as the industry standardized. So now it really feels like you're getting a physical machine, except there's a slider, and you can say, oh, make it a little smaller, make it a little bigger. So that's virtualization. Containerization is the same idea, but instead of splitting up the machine, you're splitting up the operating system that runs on it. So you run Linux. Typically, it's Linux, and then you configure Linux to subdivide itself. And what's valuable in doing that, and to be clear, Docker did not invent that. But we applied it to solve new problems that no one was trying to solve with containerization before. But that's the general idea. You split up the operating system, and because you do the splitting up at a higher level, there is just less to simulate. You only have to support this one operating system because the operating system is sort of in on the game. You can have a more efficient way of splitting. And so in practice, that means you can split up into much smaller units without costly overhead. So whereas on a machine, you could split up, your laptop into a couple VMs before you start really regretting it and burning your lap. At the operating system level, you could, in theory, have hundreds, thousands of them, because the overhead of the separation is so small. So that's the raw technology that we stumbled upon.
Okay, let me poke at this a little bit more, because I have this very visceral memory from back in 2015 when I first created my first Docker image and invoked a command line utility that was inside the Docker image. And this was a very strange experience for me at the time. But I think I'd started using virtual machines in like 2007. I had a MacBook in 2007 and like I needed to spin up a Windows virtual machine to like
Mm-hmm.
write Word documents. And every time I did that, my fan would turn on, everything would get slow.
Right.
Like it was terrible. And
Yeah.
but then, like Office for Mac got better and I never needed to do that again, thankfully. And that was like actually a big moment. Like, thank God I don't have to run virtual machines anymore. But then in 2015, honestly, I don't remember the full context of like why I was playing around with Docker, but somebody got me to do this. And I remember invoking my first command and expecting that what was going to happen was that it was like I was going to start Linux. And then after that whole lengthy boot up process, then a command was going to run. And then I was like, really? And then you're just going to like shut down the machine after this one command? Like all of this seems very inefficient. And then I hit enter and it was like nothing, just the command executed. There was no like start up the machine or anything.
Right.
So help me understand, like, where is the operating system? Is it relying on the underlying operating system that the machine already runs? I don't think that can be true because I was running Mac.
Right. So the question of how do you get that working on a Mac is its own
Okay.
problem, because the core tech is Linux based, right? So
Yep.
what happened really is we stumbled upon this raw technology, not in one place, but actually in multiple places. There were components lying around that were byproducts of other engineering efforts, mostly the race to build what is now known as cloud computing. So these hyperscalers, Amazon, Google, were inventing these giant clusters for themselves behind closed doors, but they did build on Linux and Xen and other other open source technologies. So every once in a while, they would spit out like a bone, and then the bone would be on the floor, and then the scavengers, that's us startups and hobbyists, would be like, "Oh, what's this? Oh, my amazing alien technology!" And then we figure out, how to build stuff with it. And so what we did that for several little pieces. One is Linux containers, the ability to split up the operating system, but Linux specifically, into very light little sandboxes. So you can run 100 programs and 100 different virtual Linux kernels, and it has the potential to be very fast.
Is there a term for those things? Are they?
Well, containers. Well, the back then the raw components were called namespaces,
Okay.
and another one was called C groups. So it was actually very fragmented. It took a long time for it to coalesce around this general term of containers.
And it was really like the Linux kernel that was starting to support this. It wasn't like it was Ubuntu or something like that specifically.
Exactly. In fact,
Okay.
even the Linux kernel did not support it out of the box. You had to patch the kernel, and there were competing patches. It was very early and experimental, and generally it was considered sort of a niche optimization. Like VMs were the hot thing. You have a server, you split it up, and what would become Linux containers was this really interesting, almost like a science project, where you would say, well, obviously, if it's faster and more efficient, we'll get around to using that. But on the other hand, you can't choose your operating system, right? It's only Linux. And in fact, it has to be the same version of Linux, right? So you boot a specific build of Linux, and then you say, please split yourself up into all these pieces. And that you don't get to say, this container has Linux, 2 point something. This container has, another version of the kernel. You're stuck.
So that's kind of like the one cross-container dependency. Like everybody has to take the first dependency on the version of the operating system.
Yeah, you start the operating system and then you kind of split it up further. So at this point, it was sort of a known set of low-level technology, but not considered revolutionary or even that important. It was kind of niche and like, okay, it's kind of, we'll worry about that later because it's just another server.
People thought that maybe this would be relevant for the cloud players, but it wasn't like super relevant for the rest of the ecosystem.
Yeah, like walk and then, start by walking and then we'll run later, because it was framed as a machine virtualization, a better virtual machine, a faster, more lightweight virtual machine, but you had to give up flexibility in exchange. What we found interesting was very different. We felt like it was so much more efficient, so much faster and lighter, that you could use it in a completely different way. You can change what you do with it. You could sort of, instead of doing the same thing, just a little more efficient, boot a server, connect to it, configure it. If the booting is like milliseconds, if there's no booting really, do you really need all that other stuff? Like, does it even make sense to use it in that way? What if you thought of containers not as a machine unit, a unit of machine, but a unit of application, right? Because it's so fast to run that in theory, if you had the tooling around it, you could treat it like Java developers at the time treated the jar. They had all these they had a whole system for packaging up and deploying a Java application with the Java runtime and the libraries, et cetera, et cetera. But as part of application deployment, not server configuration. And that was very exciting to us because unlike Java, Linux has a very wide compatibility base. Like if you can to use Java it was pretty great. It was pretty great tooling, but you had to write your application in Java. And the Java community tried to expand that a little bit with the JVM. So in theory, you could write your applications in other languages.
Clojure and Scala and all of it.
Yeah, exactly. And a few languages took advantage of that, but it never really took over. It didn't become ubiquitous because still it had the Java flavor. But Linux, especially with the rise of the web and cloud computing, was becoming the de facto standard runtime for all of those workloads. And so if you could somehow extend Linux with like a standard universal application packaging formats and deploy and tooling to deploy and build around that, then you could have like a lot of developers could target that runtime, right, across many languages. And so that's what we decided to build.
That framework is or the way of thinking about it is so interesting. I would not have previously put Docker in the conceptual bucket in my head of infrastructure as code. But the way that you frame this is absolutely, you're taking something that used to be defined in the machines and moving it up into the application stack. And that is like the definition of infrastructure as code.
Right. And what we were very careful to do, because the opportunity was ubiquity, right? Well, okay, there's an opportunity here to build something that a lot of people can use with very little friction. With very little friction because of the baked-in compatibility via Linux. That's what Docker was all about, leveraging the existing adoption of Linux.
That's so interesting.
But the enormous gap in tooling and developer ecosystem around Linux, and come in and propose a new de facto standard and get developers to adopt it. But because we cared about ubiquity, we had to be very careful not to cross that red line. So as we move up the stack, you're adding layers in the stack, right? So, okay, there's something missing at the bottom of the stack. Let's add a layer on top, standard that a lot of developers can target. But if you go too high, you're going to lose that broad compatibility. You're going to start doing what Java did, right? You're going to start excluding some developers, some workloads, because you have too many opinions about how to use it. So we were very conscious of that, just finding the right middle ground that it can become, like one of those hourglass shaped standards, right? All the stuff on top is compatible, all the stuff below is compatible. And then if you can sort of social engineer your way into getting people to adopt that versus something else, then it becomes this giant snowball adoption effect. And we did that, and it happened. But I'm saying that in reaction to as code, it's you're 100% right. It's a primitive to allow these things to be done as code. We're taking deep system primitives and exposing them to the application developers, making it available to them. But we're being very careful not to, for example, we're at the time we didn't do what later Terraform or Pulumi would do. We didn't give them SDKs and tell them, hey, you should write code with this way, or here's a library, or you should do it in Python, or you should do it in Ruby. And in fact, that's an important, and you remember probably because we're from the same cohort, we have the same general experience of the industry, but for everyone listening, back then, this is what, 2008 to 2013, that's sort of the incubation period for Docker. The DevOps world was early, and it was very fragmented by language, by programming language, which seems weird now. But at the time, if you're a DevOps team, you were very tied to one particular language stack, and it was either Python or Ruby or Java. or Java/JVM. Those are the three tribes. And it was very common, if you read Hacker News at the time, that you would see a launch of a tool that is basically like this other tool, but written in our language. So there was a lot of reinventing the wheel. You had Cappuccino, I'm forgetting. Like you had configuration management tools, deployment tools, and we wanted to avoid that trap. We wanted specifically to transcend these silly language barriers, and that's one reason we chose Go as the language to implement Docker in.
You weren't going to activate any of the resistance,
Right, because you can compile it to a binary,
Yep.
like the good old fashioned Unix utilities. You install it. You don't have to know what language it's written in. You don't have to pull in a whole language runtime, and that made a big difference.
Okay, this is going exactly the way that I hope this conversation would go, because I have a lot of these same thoughts as well, but they're for a different group of users, a different underlying technology substrate, solving different problems. The thing that felt clear to me at the outset was that while there is a lot of inconsistency in SQL dialect across databases, let's just analytical databases for the moment, they all have a certain set of commonalities. You can create a table in all of them. You can drop a table in all of them. There's some type of ACID compliance, blah, blah, blah. So you identified SQL as this kind of, you were talking about this hourglass. So like on the bottom of the hourglass for DBT is kind of all these different SQL dialects. And then you kind of come up into DBT and then it kind of spans out again. Anyway, the way that you were thinking about Docker, it seems like the underlying substrate is Linux. Then do you have to actually abstract across the different Linux versions? Like, did you have to do work to make that happen? Or, and then you're exposing APIs upstream to users. How closely mapped are those APIs to like the underlying Linux APIs? Or did you kind of have to add a big layer on top of that?
Well, this is where we had an advantage compared to the data world that is, I think, very, very fragmented across, dialects of SQL, et cetera. I guess the closest thing these days would be Postgres, sort of consolidating quite a bit of market share, but still nowhere near 100%. And it feels like there's a dialect of SQL coming out every day. In the Linux world, what happened is you had two forces sort of converging to create the opportunity for us. One was the incredible consistency and stability of the Linux kernel. Just the core maintainer team, same people for decades, obsessively focusing on stability and quality and saying no to everyone. And once something's in, I mean, I'm probably idealizing it a little bit, because if you zoom in, there's always trouble, but Linux is very stable and it is not fragmented at the kernel level. Linux is Linux, and if it works, it works. That is really impressive that they managed to achieve that. So as long as you target the Linux kernel, you're targeting a stable platform. You can build a wide, you can really go wide. The other force that influenced our opportunity was the absolute chaotic mess at the distribution layer, the distros, the tooling, anything above the standard library. And the standard library is messy enough, but Red Hat, Ubuntu, Debian, all of those distros.
The different package managers were such. I hated it.
Package managers, platform wars, fragmentation, drama, politics, you name it. Just an utter mess. And there is some really impressive achievements in there. And in particular, this distro model, getting a community of packagers to do the very ungrateful work of just tracking a million upstream software products and integrating them, making sure they work together and applying some sort of consistency. It was very impressive how Debian scaled that and how Red Hat scaled it, for example. But it didn't really keep up with how developers actually work. So I think it's hard to believe now that Red Hat, like the actual Red Hat distro community or Debian, that was considered like relevant to developers. Like you had to talk about getting your software in there and just have that as a distribution method. And these days it's for sysadmins, right? Or it's like you need your tool, so whatever, I'm going to apt get install that, or deb whatever, RPM. It basically they didn't keep up, right? It's not relevant to developers, to most developers, what happens in that distro. But nothing really had at the time replaced that. There was no equivalent of the iOS platform for mobile developers, right? Or Windows for mobile developers, like a consistent end-to-end experience. Okay, this is what I'm writing my application for. This is the platform I'm targeting. That just didn't exist. It was just completely fragmented. So if you take those two forces, incredibly stable and a ubiquitous kernel that everyone's running at the end of the day, it's there everywhere for the context of web and cloud, right? And utter mess on top. No one's really able to capitalize on that. That's what created the opportunity for Docker, because you had millions of developers just dying for some sort of consistency, a tooling that allowed them to just get the job done and ignore the noise. So it became Linux plus Docker. That's all you needed.
Yeah. So I became aware of a term that was used inside of VMware in the late 2000s. There was a term that they used called VM sprawl, where it turns out that sometimes you invent a thing that has it reduces friction so much that lots of people use it, and there are good outcomes from that, and there's also some level of chaos that comes out of it. I don't know how much you hang out with data engineers, but a super common usage pattern in the data ecosystem for Docker is you got an Airflow instance, and a bunch of teams throughout the company publish workflows to this Airflow instance, and each of those teams will ship a Docker container along with their pipelines, and that Docker container contains all the configuration required to run their pipelines, which from some perspectives is lovely because everybody gets to do their own thing. But from other perspectives, it feels a little chaotic. You can have dozens or even more teams kind of doing whatever. How much of the way that Docker is used internally today, does Docker even have an opinion? Like, is it just foundational technologies absent any opinions on like how it should be used? Or does Docker, the product, kind of like have opinions about how one should use it?
Well, first of all, I left Docker in 2018.
Sure. Yes.
I know you know that, but it seems important to mention. And I'm working on another startup called Dagger, which aims to answer part of your question. I think Docker, as most people know it, is basically the products we built before I left. Docker Engine, Docker Desktop, Docker Hub, Docker Compose. And to be clear, there's a team at Docker now that did an amazing job at keeping that going and improving it. And honestly, I think it's easily neglected, the importance of follow-up improvements. It's cool to say, well, I built that. And most of the people a lot of the people who were there building it, they're still there maintaining it, right? But my point is, the adoption of those original core products was so massive that initially Docker, we made the mistake of not being content with that and trying to build more enterprise products and sort of widen the range. But eventually the market sort of forced us to focus on the core. When you have so much growth on the core, why would you not focus on the core? So that's what Docker is doing now. But the trade-off is these days they're not layering that many opinions on top. I mean, I know they're building add-on products and sort of filling the gaps, but the thing is, it's that crazy wave of the container hype is over, right? People use containers.
It's just a fact of life now.
It's a thing that you use at the moment. Docker doesn't have the influence it used to have to expand the standard. It's a successful business. It's a player in the market, but it's just another player in the market. When we started and containers sort of seized the moment, we were like OpenAI now at the center of this AI tornado. If we said there's this new thing in Docker now, people are like, holy shit, game changer, you had an influence on the standard that is now gone.
Who actually maintains the core? Is there like a single GitHub repo that kind of defines the standard?
Oh, well, it depends what you mean by the standard. When I say the standard, I mean the de facto standard of the tools and how people use them. So that's a combination of the Docker file syntax, the Docker CLI, what Docker Hub can or cannot do, Docker Compose, and what goes in the file. I would say those are the four.
And these are all things that are still maintained by Docker, the company.
Yes.
Yeah. Okay.
Now, meanwhile, there's a layer below that, which is a set of formal standards, and that's the Docker image format and the protocol for downloading it from a registry. those were also invented at Docker, but at some point sort of spun out into more formal standard bodies for mostly just competitive reasons. Like you have to, anyway, that's just how standards work. One company breaks away, com- competitors get together and say, hey, let's do a standard to slow them down,
Got it. Got it.
So that also exists, but all of that I think today blends together for most people. It doesn't really matter what's an actual standard body and what's just software that everybody uses, open source software that everyone uses. Those are just harder to change now, so they keep evolving, but the main job is keep them stable, keep them good, improve them incrementally, don't surprise people too much. And I think that left a gap because we were on a mission, to apply this container tech all the way to really transform the developer's experience, make it really easy and sort of obvious how to get your code out there working, and we never finished.
What were the things that circa 2018, the time between when you left Docker and started Dagger was what, a year-ish?
Yeah, something like that.
And I have to imagine that during that year you were
Resting.
doing a little resting, maybe a little backpacking through Europe, but also like smarting over the fact that like there were unsolved problems yet.
Yeah, a little bit of all of that, a little burnout, a lot of. I was a full-time dad, actually. That was my main thing. Not so much backpacking, but it was very fun. But yeah, that definitely, the list of unsolved problems are in the back of your head, and also leaving the building and just talking to people not through the lens of being a vendor. Even the most open-minded vendor, when you're talking to people in the market, you're wearing your vendor hat,
Yeah,
right? You're
sure.
thinking, how do I apply this to, like, what do I escalate to the product team? How do I pitch this new feature? I wonder if we're missing something on the roadmap. And then, but when you're outside the building, it's completely different. You can really just take it in for what it is. And first, it made me internalize just how many people use Docker and how much of an impact it had. It seems silly, but when you're inside the building, you're just so focused on the next feature, the next bug, the next user conversation. Genuinely, like, okay, we're bigger now. Like, but it doesn't really hit you really until you're on the other side. You're in the ecosystem and you're building stuff on top of Docker. So that was the first part, and then you talk to people, and then you realize you had a lot of assumptions about problems that surely someone's fixed on top of container technology because it seems so obvious to you. Okay, we're building this core. There's a whole ecosystem now. Some problems are just obvious, and you can solve them now with containers. And there's such a huge, sprawling ecosystem, startups, big companies. Surely someone has solved this. And then you go out into the world, you talk to your friends and software engineering teams, and you realize, oh wow, it hasn't been solved, but it's right there. Again, the tech is here on the floor. Why hasn't anyone picked it up and solved it?
Is the answer to that nobody has figured out how to do it, or is it that just that nobody's done the work to get the industry to coalesce around a given solution?
I don't know. I think
Before DBT came into the market, there were lots and lots of people that had kind of one-off solutions that were DBT-like. But the main problem that we solved was not like, oh, wouldn't it be a great idea if you could define data transformation in code? It's like, let's actually smush all these people together and get them to use a common framework to do this stuff so that you can kind of collaborate on it.
yeah. I mean, you got to build it. You got to get people to use it. I mean, it's hard. It's hard work, right? But it's so competitive. To me, there's so many smart people that are exposed to these problems. Like if you zoom out from Docker specifically or DBT specifically, if the tech exists and the problem is real, surely someone will emerge to solve it, right? I feel like most important problems are that way. We just got lucky and we're the right team at the right time to do it. But there's probably a few other people behind us, not that we're going to figure it out soon enough. So it's always surprising when you see that gap. You say, wow, okay, I guess I'm in that gap where it could be us. Like if we want, we could solve this problem.
What were the problems that you chose to pick off the shelf to work on after Docker in 2019? You made the very questionable decision to become a second-time founder.
Indeed, very questionable. I agree with that. Yeah, I mean, I did it for the thrill and also to bring the team back together. I'm working with some early Docker people, and we've kind of shared that feeling that, okay, we're not done here. And it's just fun. I mean, nothing beats the feeling of building something great with a great team, like you're high-fiving, like, holy shit, we did that. So that's it's the love of the game. But yeah, the problem we got pulled into is, application delivery, just those CI/CD pipelines, to use a rough analogy with that shipping container analogy, right, that we use for Docker. Like, okay, there's a standard way to package up your software component so that it can be transferred and deployed and it can run in this standardized way on this whole ecosystem, regardless of what's inside. But turns out, if you look inside, you realize, okay, how is this assembled? So just upstream from the container, what goes into the container and how is it assembled? How is it built? How is it tested? How does it all come together? So I guess we went from the shipping problem to the manufacturing problem. And we this is one of those situations where we thought, surely everyone's figured out that you can containerize not just the application, but also the whole set of pipeline and scripts that ships the application. Because these days the application itself is so complex, you can't build and deploy by hand. Very quickly, when it becomes a real important software project, you have specialized software just to ship your software, right? So there's an application building and shipping the application, and there's usually a team of engineers in charge of that, right? We call that the software factory, because that's how complicated it gets. That software factory is way behind in terms of software quality, software standards. It's a kind of a color without shoes situation,
It's still very scripty.
where developers get all this cool tooling using container technology, but the engineers giving them the tooling themselves don't have it. It's like duct tape and bash scripts and YAML and all the same problems that Docker solved initially.
Yeah, which is the way that things would have looked in 2008, 2010, if you were looking
Exactly.
at software
Yeah.
development more broadly.
Yeah. But the problem is, to see the problem, you first have to set the bar higher, set your expectations higher. Because if you told a developer, hey, so here's the deal, you're going to develop this app and your dev loop is going to be like 5 minutes. Like every time you make any change to your code, the shortest amount of time you're going to have to wait to see any result at all is 5 minutes each time. Not 5 seconds, 5 minutes. They will go insane, right? And then I'll say, oh, and also it's a little complicated, but it has to be on this one provider over there. It's proprietary. Like the code you're writing, it's not some open source language. It's a language that can only work on this one company's servers, no one else. So if they're too slow or too expensive, or they're missing a feature, that's it. Tough luck. You have no options. Again, they would go insane. That's the situation that DevOps teams operate in with their CI/CD, their delivery pipelines. You can't run locally. It's all the same problems, right? It's not standardized. It's not open. So we focus on that.
One of the interesting things about Docker is that it's not only relevant for kind of internal proprietary use cases within a company, but it's also just as relevant for there's an open source angle to this too, where somebody will. I was talking about Airflow before, but like somebody will package up Airflow in a container, and that will become kind of the de facto way that people get Airflow installed.
Right.
Alongside of a Docker file, will there be a Dagger file of like this is how to?
Good question. Well, this time, unlike Docker, we changed our tack on this. This line I was talking about. Like, okay, where's the line for ubiquity here? With Docker, we had to be very careful not to have too many opinions, which means also not to add too many features. Right? You had to stick to the features that you could get everyone to use. So you were limited in your ability to improve the state of the art, because you want to improve the state of the art for everyone, not for just 1% of developers. That was the constraint with Docker. In fact, back then we got a lot of criticism for that, because if you're a purist and you decide the worth of a technology based on the worst way to use it, what's the least clean Docker file you can write? Like how many mistakes does Docker allow you to make? Then you're going to grade Docker very harshly, because Docker allows you to improve incrementally. It doesn't force you to throw away your architecture, throw away your tooling. It's an incremental solution that allows you to gradually solve problems, and that's how we got adoption. With Dagger, we have a different trade-off, because we're not trying to run every application. We're trying to run a very narrow type of application, software factories, right? Your CI/CD pipelines, your build, your tests. We're saying that's software. You need to containerize it, and you need a specialized platform to run these containers in a really awesome way so that everything's just better. But because it's so narrowly focused, we can afford to add more features, to have more opinions, because every software factory is different, but there is an ideal architecture for software factories. And we can tell you what it is, and we can optimize for it. And specifically, in our case, it's a DAG, boxes and arrows. We tell you, here's how you should architect your software factory. It should be functions that are, very repeatable and produce these immutable objects. And then these objects can flow through more functions. So you're building a graph of these repeatable operations with immutable data flowing through it. That's how make files work. That's how every good build system works. And that's how Dagger works. We're just doing it with containerized primitives. So it's more generalizable. So the big difference is that we don't have to compromise on something like the syntax of the file, like a Docker file syntax. To answer your question, it's very simplistic because we had to. Because if we made it too advanced and complex, then we wouldn't be ubiquitous because people would just fall off. And here we have an API, we have SDKs. You can say the way you drive this thing is code. Here's a Python SDK to program your Dagger pipelines. Here's a Go SDK. Here's a TypeScript SDK. We have a deeper stack, I guess.
It's very interesting to hear you talk about the difference between build and the way that I would describe what you're saying is like the difference between building a product and building a standard. And you have to think about those two things differently. If you achieve your wildest hopes and dreams for Dagger, I think I was looking at the current quoted number is something like 20 million developers use Docker, which from my perspective, does that mean that there's 20 million developers in the world? Because I think appreciably all developers use Docker.
Right. I don't know.
But is the target set of humans interacting with Dagger in 10 years similar, or is it a subset of that?
I think it's similar in a different way, a different type of interaction.
Yes, certainly.
Yeah, I think it is similar. I think the unsolved problem is that most developers fall in two categories. They're either building something on their own, or they're building something as part of a bigger team, for work, typically. If they're building it as part of a team, then they're building on top of a platform that is specific to that team. Again, the factory. And each of those is unique. And so there's an indirection. There's really two different users in the picture. There's the application developer building something, and then there's the platform engineer building the foundation for the application developer to build on. And that foundation needs to be better, right? It is its own product. The way we think of it is our direct customer, like the person we serve, is that platform engineer. And there's way less of them, but they have a multiplier and they have a huge leverage, right? Because one platform engineer will serve anywhere from a few dozen to a few hundred, or if they're really overworked and it happens, a few thousand developers. And they just have, they're burned out a lot of the time because they're a natural bottleneck. So our focus is to make them more productive and happier so that they can be the heroes. And the developer is one level removed from us. We want them to have an awesome experience, but we don't care if the developer in the end credits Dagger itself for the awesome experience, or if Dagger is just a hidden ingredient. And developers, as far as they know, are using their in-house platform. And there's some magic that makes it really good. So that's one difference with Docker.
I think that I want to hit you with one final question, and then sadly I'll have to let you go. But I was looking at your site, and your site makes mention of AI and agents.
Mm-hmm. Yep.
I think that probably wouldn't have been true a year or two ago.
Oh, that's true. Even 6 months ago.
Yeah. Okay. So my guess is that you didn't architect Dagger anticipating agents.
Also true.
But that along the way, you found out, and this is just my hypothesis, but that you found out that there are real similarities between the workflow engine that you're building for human platform engineers and that agents need to take advantage of. Can you talk about what was it that you found out there?
In the last 6 months, Dagger went from no mention of AI whatsoever to a pretty significant share of our website talking about AI agents. in the context of this software factory that I've been talking about. So not some random AI pivot, but
You're not trying to like create AI agents for the support team.
right. It's not agents for the sake of agents. It's agents at the service of serving platform engineers, helping them build a better factory to serve their developers. And the way that happened, in fact, is that we have a very active open source community, and we have an architecture that is designed from first principles. So internally, we talk about Lego a lot. People apply Dagger primarily to CI/CD, but it's not designed as a CI/CD product. It's designed as a general purpose operating system for workflows that just happens to work great in CI/CD, but can be applied to all sorts of problems, including there's some data engineers, by the way. It's definitely a minority, but there is some overlap between data engineering and Dagger. And so the role of this open source community is to go and explore all these different use cases and come back, and we have a Discord server, and they're showing each other cool ideas and cool applications. So it's like an 80-20, right? 80% CI, 20% long tail. And what happened is the community started coming back with these AI agent demos. Like, hey, look, we built an AI agent running on Dagger as an engine.
Can you give me an example of like one demo that struck your fancy?
The first demo that we got was actually embedded in CI, which is really interesting. A workflow that for each pull request would look at the tests, would run the tests, and then would generate a test coverage report, and then would figure out gaps in the test coverage, and then would have an agent wrapped inside of a little function, sort of develop additional tests to increase the coverage, and then open a follow-up pull request on top of that. So that kind of blew our minds, and we went through a process of our community educating us on what an AI agent is and why Dagger is even relevant, which is just hilarious, but also so rewarding because we set up Dagger in the hope of a moment like that, so being educated by our community and then building the solution together. But yeah, I mean, the bottom line is AI agents, and especially these coding agents that are coming up, they're completely blowing up the concept of CI/CD. They're blowing up the barrier between what belongs in the IDE, in the dev environment, what belongs in the backend in CI.
Yeah, that's interesting. CI/CD was essentially the humans did their part. Now it's the time for the machines to do their part.
Exactly.
Whereas now it's much more back and forth and
Exactly.
interactive.
It's totally mixed. It's like humans and machines sort of all living within this one big delivery
Factory.
life cycle. Yeah, factory. It's a factory. It used to be the robot arms, like industrial robots doing their part, a script here, a CI script there, and then humans just sort of running it. But now you have an actual sort of pretty intelligent robots in the factory working there. And so how do you redesign the factory around that? It turns out in addition to being very cool tech to play with, it's the defining problem for this space that we're in of software delivery. Like if you don't have an answer, you're probably not going to exist in a few years, in the DevOps space. You can't just keep doing CI as usual. It's not going to work.
Yeah, quickly getting commoditized. Solomon, thank you so much. This has been a fascinating conversation. I appreciate you taking the time to educate me here today.
Oh, my pleasure. Thanks for having me. This is fun.
The Analytics Engineering Podcast is sponsored by DBT Labs. I'm your host, Tristan Handy. Email us at podcast@dbtlabs.com with comments and guest suggestions. Our producers are Jeff Fox and Dan Poppy. If you enjoyed the show, drop us a review or share with a friend. Thanks for listening.